Hello, here we are after the first quiz of Unit 7, and here's some Algebra 2 for you. I keep saying in class there's been lots of preview moments when we get really close to talking about the two reflection theorems or what happens when we start putting more than one geometric transformation together and all that kind of stuff. We will get to that. That is not the subject of this lesson. This is getting us really close, though. This is about function composition, or in other words, doing one function and then followed by another one, but in an algebraic sense first. You may remember from the exponents and logs unit, we did that kind of thing, f of g of x. We also wrote that this way, f of g of x, when we looked at trying to figure out inverses and that kind of thing. But that was just about exponents and logs and really for the sake of doing inverses. This uses that notation and that kind of two-function process, but it's a lot more general and more applicable to other things. Okay, so they have you do this warm-up that actually has you talk about this function and transforming things. This would have been okay for us right now in the unit if this 1/3 had not been here. So let's not talk about the 1/3 for now. If you look at the Algebra 2 answers, the 1/3 is going to be in there. It happens after their one part of lesson 1.3 that we haven't done yet. So that's a little hiccup for now, just because it's a warm-up. I don't think that's going to be a problem the rest of this video. But let's just pretend that that 1/3 wasn't there. We're just talking about this, f of negative x plus 5 plus 4. This actually isn't totally something we've talked about before, but I did talk before about this order of transformations in every class, that we need to be following the order R, S, T. And that order stands for reflect, do any reflections that you think you might have to do, then do any stretching you may have to do, and that's the thing we haven't talked about yet, and then do any translations to get that final thing where you need to put it. So we do have again, we haven't really done stretches yet, and that's the part that would have happened here. That's, again, a little preview of what we're going to do in part 3. I hope you're not confused yet. Okay, so let's talk about the reflections and the translate. This little part right here, this negative, this represents a reflection, and if you remember correctly, that's a reflection over the x-axis. And then these little parts have to do with a translation. And I could actually specify what translation that is now. A little better handwriting here. This translation, if you translate a plus 5 on the inside, that's going to be a translation of 5 to the left, and a plus 4 on the outside is going to be a 4 up. So I just described the transformations in the correct order. That we're going to reflect over x, now we're going to translate negative 5 comma 4. And then if negative 4, 6 is a point on the original graph, what are we going to figure out? What's the corresponding kind of inputs and outputs that we're going to see resulting from the graph here? You could think about how to take 4, 6 and do these things to it, but I think it might be easier to think about 4, 6 algebraically. Like if we want 4, 6, basically to find the analogous point that 4, 6 kind of produces on this graph, think about this whole thing and the input being 4, then we'll change the output of this whole thing. We know it will have to be 6, and we'll go from there. All right, so if negative x plus 5 has to equal negative 4 for this thing to make sense in the first place, we're going to have to operate as if x were, gosh, can you do this in your head? X will have to be 9. Yeah, x will have to be 9 for that to work. So x is going to be 9, and then when we stick 9 in here, this whole thing turns out to be f of negative 4, and we know what f of negative 4 is. F of negative 4 is 6. Then this whole thing, 6 plus 4 will be 10. So this was the original input, and this is the original output. So it turns out to be 9 comma 10 is going to be the corresponding point. That's, again, some preview, some review of other things. That's not the main focus of today, but that's a fun little thing to get started. Warm-up number 2, we're transforming some little functions here and seeing what happens. Okay, write the new equation. Yeah, fundamental property of this unit, and you were just quizzed on it. We transform without any reflections or dilations so that there's a maximum at negative 2, 0. So no reflections, no dilations. The only thing we have left, and by that includes the stretches that I was talking about up here. This is only going to, like, what's left with no reflections and dilations, and I don't know if I've said this enough, we never do rotations in algebra, because if you rotate things, they usually turn out to not be functions. The only thing we have left to think about really are translations. The maximum is going to become negative 2, 0. So right now it's here. This is going to be, since we're not reflecting or anything crazy, we're just really able to translate that. This point still has to correspond to the maximum. Anyway, the new maximum is supposed to be at negative 2, 0, which is right here. So it looks like this thing has to take a translation that kind of goes that way. That will be a translation that goes negative 2, because it's going 2 to the left, and it's going 4 down, so this is negative 4. So again, we're taking translation of -2, -4. If this is f of x, this original thing is f of x, what we need to be writing about, or how we change that in here, is we put x plus 2 in there, and we put a -4 on the outside. That will be our new function. And it goes to 3 transformations so that the domain goes from -4 to 4. And let me just check this out. Yeah, this is going to involve stretches, so this is later. I can tell by the size of these things that it's not going to occupy the same size domain and range as it did before. So I don't need to make this video unnecessarily long or confusing. I promise we will go over that after we've finished all of 1.3, which happens later. Last one. For what values of, oh yeah, this is almost like the first section. Use the graph below to answer the following questions. For which values of x is f of x greater than 0? Now be careful about keeping these things straight. There's an f of x and a g of x. F of x greater than 0. F of x is the curly one. Where is it above 0? It's above 0 here, and it's above 0 here. And since it's equal to 0, I'm probably going to want square brackets on all this stuff. So it's above 0 from -infinity up until we get to about -2 point. Oh, I hate it when they do this. Let's say 2.5. Let's not think about this too long. It's also above 0 when we go from about 1.5 to about 7.5. Those are estimations, but they're included, right? Because there's whatever point we believe, I'm showing that we actually do believe it's on it can be on the axis. For what values of x is f of x greater than g of x? Okay, this is a fun question, because now we're talking about two functions at once. Where is it that f of x is kind of on top of g of x? So that's going to happen. Oh, maybe I should use a highlighter. I don't want to use a gray highlighter. Okay, so it's on top of, it's greater than g all the way down to there. It's greater than g from here down to here. This is the part where, again, I'm looking to see where is f of x above g of x. And it intersects there, and it intersects there, and it intersects there. So we're not talking about the axis. We're not talking about 0. We're talking about it bigger than the other function, or, north of the other function. So we mean by bigger. We're talking about the y values being greater than. So that's going to happen from -infinity, because these things both go to -infinity, up till it looks like -2 exactly, or equal to, so I'll count that. It's also greater from 3 up until 8, or equal to, I'll count that. And where is it less than? Well, less than is going to be everywhere else, so not there, not there. It's going to be less than if we're in here. Oh, sorry. It's less than if we're in here. Where is f of x, the one on the bottom? The one south of the other one. So basically, it's the places that we're not part of part B here. So from and it's just strictly less than. So not -2, but starting at -2 up to 3, not including 3, and also from 8 to infinity. These both go to infinity. Okay. All right, operations with functions. Not really part of the title, but okay. Operations with functions. If you're given, this is pretty good wording. If you're given two functions, we're talking about f of x and g of x, like we've been talking about before, that's what we mean. We could add those two things. We could subtract those two things. We could multiply. We could do any of these operations, and we just do the same thing we would do in normal algebra. Perform the following operations, simplify these things by combining like terms. I trust you could do this. I don't think this is something that you guys are going to struggle with. I'll just bang these out really quick and watch how many mistakes I make. And what's the last one here? Oh gosh, this one's going to take forever. 2x squared. Oh, I might as well be careful about it. Do it that way. Sorry if that was painful to watch, but okay. Okay, great. I think that's just reviewing there for algebra students who had a vacation year from algebra when they did geometry. Remember, this is the first unit of the year for Algebra 2 kids. So, all right, we have a f of x machine and we have a g of x machine for the next few questions. Use the appropriate function machine to evaluate the following. So f of 2 means we're going to put 2 in here, and we're going to see what gets spit out. That just means f of 2 is, I put 2 in there, so it's 4 minus 1, which is 3. G of 2 is if I put 2 in there, and I would do 4 plus 3, and I get 7. So f and g do two different things to the number 2. Like I'm putting 2 into each one of these, but f turns it into 3 and g turns into 7. Kind of like something like this, back in this function. Now let's say you input the value x into -3 into f. Okay, well we've done, I mean, that's easy, right? -3 in here is going to make -6 minus 1. I get -7. F of -3 is -7. And then we turn around right away and we stick this into g. So I'd say g of negative 7 is, and I put it in there, I get 49 plus 3, 52. So what's new here, or what they're about to talk about, is this is g of negative 7, yeah, but it's also g of f of negative 3. I did f first and then g. This is g of f of negative 3. In this notation, f is the thing that happens first, which I think is easier to notice here because it's the thing inside the parentheses. Anyway, that's what we just did, and that's the idea of performing one function and then another. And that's called function composition. And I think I just went through all of these, all of this explanation before I got to this page. We often describe function composition as substitution. That's not my favorite way to talk about it. We'll use the term composition a lot more when we're talking about, or it's a lot more standard, I guess, to use the term composition when we're talking about geometry. It's just one function and then another. If you want to make a general rule for it, this is what's going to happen next. That's what's going to happen kind of down here. They have you doing just one number again at, for example 3. Example 3, I'm going to find g of 3, and then whatever that answer it is, I'm going to find f of that. So let's find g of 3 first of all. G of 3 is, because it's asked me to find this. So when I have to find this, the first thing I have to do is the part that's inside the parentheses, and that's g of 3. So that's your order of operations kind of thing that you're used to. So g of 3 is this, which is, so I didn't write all that kind of stuff up above. That's 2. So now I need to find f of g of 3, but I know what g of 3 is. G of 3 is 2. So I'm finding f of 2. I put 2 in here, and that's going to be 4 minus 6 plus 2. That's not too bad. Is that 0? Yeah, that's 0. F of g of 3 is actually 0. Given f of x is, I'm looking at example 4 now, f of x is x minus 3, and g of x is x squared. Find f of g of x in general. Well, that's like, again, finding f of g of x, which is like finding f of, well, what's g of x? It's x squared. Okay, so we did this back in the exponents and logs unit. It's now like we're going to use this now as the input into the f machine. So what that looks like is everywhere it said x before, we just now use that kind of surgically as an x squared. So it's like there's your x minus 3, because now we're finding f of x squared. And you can leave it like that, or you can make it look a little prettier. You can simplify as much as you want to. Generally speaking, I don't require any kind of simplification on a problem like this. This one was pretty easy to look at, but sometimes they get really messy. And it's not, if I tell you you don't have to simplify, it's kind of a good piece of advice. Just don't simplify, and then your life is easier in terms of points and making mistakes. If you don't need to go there, just don't go there. G of f of x. Well, f of x is x minus 3. Let me get some of this junk out the way. And g of x minus 3, I'm going to put x minus 3 in here. So be careful. That's x minus 3 as the old x, and then there's a square on it. And again, you could leave it like that. In fact, I'm going to leave it like that. If I expand this, it only opens me up for making mistakes, and there's no need to do that. I'm going to make this x a little prettier, but that's it. You could. There may be a reason to do that, but not for my quizzes and tests. Are the equations for these two things the same? No, because f of g of x is this, and g of f of x is this. If you weren't sure they weren't the same, okay, maybe there's a reason to expand them. Like, yeah, I know this is definitely not the same thing as the thing above it. So, no. Yeah. And then, example 5, is that it? Yeah, this is pretty short. Okay. Example 5. What's g of f of negative 1? Well, if you're doing g of f of negative 1, you don't have to do the whole g of f of x thing like I was doing up here. You could just stick negative 1 in the places you need to put it, and that might be easier. So this is g of f of negative 1. F of negative 1 is there's a negative 1 in there. That's 3 times negative 1 minus 1. That's negative 3 minus 1 is negative 4. Now I need to find g of negative 4. That's now I'm putting negative 4 in here. So it's 16 minus 8 plus 5, which is 13. F of g of negative 1 will be f of g of negative 1. G of negative 1, again I'm putting it in here, is 1 minus 2 plus 5, which is, I don't know, 4. Then I put 4 into the first one. I'll get rid of this. 4 into here is 12 minus 1, which is 11. Do you get the same answer? No. Yeah, okay. And now find the equation. So we could have done this equation first for g of f and then try to do something like this, or, you know, in the order they asked me to. And then we could check it. This is g of f of x, which is this. So now I'm putting this in to g wherever I see x. So that's old x squared plus 2. See how much easier this is now? X plus 5. It's so much easier now after we've done the exponents and log chapter. I mean, and I said you don't have to simplify it. You don't have to simplify it, but I just know some of you couldn't sleep at night if you didn't see this. So this is minus 6x plus 1 plus 6x minus 2 plus 5. I mean, really, for my money, and I'm just going to reiterate this, for a quiz answer, that's perfectly good. But again, since some of you can't sleep at night, including me, I'm going to go ahead and do this. 9x squared. The 6x's cancel? Well, that's interesting. 6 minus 2 is 4. Plus 4. It's almost a difference of squares, but it's a plus. Okay, I guess that's it. I will see you in class.